So now we're going to take this region. We did A in a previous video, the area. Now we're going to find the volume of this when we revolve it around the horizontal line y equals 8. So let's give ourselves some room. Y equals 8 is this horizontal line up here, and that's where we're going to revolve it. So just like area, we're going to take one representative rectangle right here. We're going to revolve that around this line. And then we're going to add all those resulting volumes together. This one revolution is going to be the volume of a washer. Pi r squared h would be the whole cylinder. H is delta x, which is just going to be the dx in our integral. So this is how you know it's with respect to x, because we have a dx here. If we're revolving it around a vertical line and had to draw the rectangle like this would now be a dy, and it would be with respect to y. So we are using the washer method, so our rectangles are always perpendicular to the axis of revolution, just like I have it drawn. So our limits basically are, we have to tell the integral when to start adding and when to stop adding. So we're in this region, so we need it to start adding at x equals 0, and we want to stop adding all those volumes together at x equals 2. So now we just need to figure out what the formula is for disk method, if you recall, is pi times the integral from a to b of big R of x squared minus little r of x squared dx. So we have to figure out what big R of x is. Big R of x would be the outside of that big cylinder formed when revolving it. So basically the farthest distance from your rectangle to the axis of revolution. And now you just measure that length. And measurement never changes. If you're measuring vertically like we are, you take the top end of the arrow point minus the bottom of the arrow point. So these are all with y values, right? So the top arrow is always on 8. And the bottom arrow is always on this graph, which is that value of y, which is natural log, or I'm sorry, 4 times the natural log of 3 minus x. So all we're doing is just measuring this length, the top y minus the bottom y. Now we're going to have a big void in the middle, a big center cylinder here. That's going to be, at least the radius is going to be this big. And that's little r of x. That's really the radius of the hole. So basically little r of x is you measure to the axis of revolution, just like big R of x, except you measure the short distance now, in this case, the top of the rectangle. The best thing is that measurements never change. It's always the top of the arrow here minus the bottom arrow. So this is y equals 8 minus, now the bottom of this arrow is consistently on this y equals 6. So little r of x is 2. So now that really makes a lot of sense, because you know the distance from here to here is always 2. So we're done. We just now have to calculate, and this is a calculator question. So what I'm going to do is this is pi times r of x squared. So 8 minus 4 ln of 3 minus x squared minus 2 squared. parentheses are a little off there, but that should work. It's a calculator question. I'm going to go right to the calculator. I have 8 minus all of that squared minus 4, which was from 2 squared. Hit graph. We're going to integrate that from 0 to 2. I don't know what I'm doing. Let's try that again. Integrate that 7 from 0 to 2, and we get 53.533. 53.533. Now remember, there's a pi out there. I think I just copied that down wrong. 53.533. That's right. And there's a pi out there. So you can just throw the pi in, or you can just multiply your answer out here times pi. It doesn't matter. I would just leave it as, I would just leave it as I already put it, but and you can see I definitely should have left it as I already put it because I'm having a real hard time here. Or 168.179. Or 180, you can see if you round it up. So that's it. Those are easy, but you need to practice them a lot. Once you get the hang of it, it becomes really, really easy. So have fun practicing.